What exactly is a relationship? A relationship is some kind of relationship between X and Y. Sometimes those relationships are not so readily seen, like you may not know if it's a function or not, but it is any relationship that X and Y has. So this relationship can um, easily be shown. So let's take a look at a few relationships. Right. So an example of a relationship between X and Y could just be as simple as this graph. This has a lot of points here. This will be like a scatter plot. There's some relationship between X scores and Y scores. These are all varying relationships. Some are functions, some are not. So anytime you're talking about a relationship, it's something to do with any kind of relationship, mathematical relationship between the variables X and Y. So now we're going to talk about what exactly makes a relation a function. So let's take a look. Relation is a function. I'll write it out. A relation is a function if any X value only has one Y value. That could be a little confusing. So when we think relationships and if there are functions, you always want to just look at your X. Is it a function? You can tell by whether or not X is repeated or not. If X is not repeated, it is a function. If Y is repeated, it can still be a function, it doesn't matter. But if X is not repeated, it is a function. There's a couple of ways people like to represent relations. A relationship can be represented in the format of what they call mapping. With mapping, you'll have two oval shape, and then you'll have one of the ovals labeled P for domain, and the other oval labeled for range. Now, domain is X and range is your Y. So let's say, for instance, we had a series of coordinates. Right, so sometimes what they'll do is they'll put coordinates in brackets and then also parentheses. So we had this as a coordinate. And so what you would do is you would take these coordinates, you would separate them by X and Y to state whether or not they're a function. And so you want to look at all of your X values and say what they are. So we have an X of 0, X of 3, X of -1, and X of 6. Now what you want to do is you want to go in order from least to greatest. So our smallest X value, let's get this close, I'm sorry. All right, so our smallest X value would be -1, then we will go with 0. And our next X value would be 3, and then we have 6. Space these out some. And then you will go to your next values, which will be your Y values, and you will go from least to greatest. So we have 1, 5, 6, sorry, not 6, 1, 5, 7. Then we have 9. And when you map them together, all that has to do with is drawing a line. So 0 was paired with 1, 3 was paired with 9, -1 was paired with 5, and 6 was paired with 7. So you ask yourself, is this a function or not? The answer would be yes, because each one of these domains only have one line coming from it. Now, if turned around and had another coordinate added to this, and that coordinate was, let's say, 0, comma 7, then that means there will be another line drawn from 0. And that 0, comma 7 will make that not a function. Now, let's say we had another value like 2, comma 5 added to this. 2 would go in here, and then I would have to map that to 5. This would still be a function because each x value only has one y value. Although this 5 has 2 x values, the fact is that each domain only has one y value. So because there are no repeated x's, then you can safely say that your relation is a function. Hope that makes sense. So let's take a look at when they give you a graph, okay? So if they give you a graph like this one, this relationship is not a function because if you look, if I drew what is called the vertical line test, I would pass through the graph more than once. So in this case, definitely not a function because I would pass it at this point, this point. So that means there's a repeated x value. Let's take a look at another one. This would be a function because if I were to draw, and I'll just show you, if I was to draw straight lines, I only hit graph in one location. Excuse me, that those are not really straight. I only hit my graph in one space. And because of that, this is a function. Now, if they give you an equation, and they ask you whether or not it's a function, all you have to do is take that equation and graph it into decimals and see whether or not the relationship is a function. For example, they gave you g of x is equal to, let's say, x squared plus, we'll do minus 8. We look at this graph would be a function because, again, if I did what they call vertical line test, just drew vertical lines. Well, that's a slanted line. If I drew vertical lines, I would only hit this graph in one location every single time. Because I'm only going to hit it in one location, this graph would be considered a function. Sorry about my slanted line. So that is how you determine whether or not the graph is a function. If you didn't get anything out of this, I want to make sure that you understand this. There can be no repeated x values. So if something is a function, then it has no repeated x values. The y values can be repeated, but the x values are not repeated. So let's talk what domain and range is and how to actually explore and to find it. So when you're talking domain and range, sometimes it can be a little difficult because it's like, what does that really mean? And when I'm looking at a graph, why can't I tell right away what domain and range is? So if you were given a table and they're asking you to find the domain and range of this table, you will only be looking at the x values, and then when you write out the domain and the range, you will write it out in this format. Say that the domain, colon, curly bracket, is 1, 3, 5. You close it off with curly bracket. And you do the range the same way, curly bracket, 2, 4, 10. You want to go in order from least to greatest. Now, in a case like this, grocery store is selling peaches for 0.98 per pound. We need to write out the equation for that. Y equals 0.98 per pound. So from here, I would need to see what the graph look like. I would go to Desmos and I would actually graph it. I know it's going to be a line, and I already know what the domain range will be. I want you to take a look at it, but it will look like. All right, so we have y equals to 0.98x. You see how it's a line? So technically, this line has arrows on both ends. So we have an arrow here. We will have an arrow here. And then we would also have an arrow here. It means that this line is going on forever in both directions. So what does that mean for us? It means that all real numbers is a domain. All real numbers is the range. So the x will keep going all the way down, which will go all the way this way. There will be some value of x all the way to infinity. And then y, we don't know. There'll be some huge amount for a billion of these pounds and some negative amount for a negative billion. So because it is a line, it's going to go for, because it's a line that is not, because it is a line that is not vertical or horizontal, that means that it's going to go forever in those directions, infinity and negative infinity. So you have what is called all real. So I want to show you how you would need to write that out if you had all reals. So when all real numbers is your domain and range, do what is like a funky little R. So we would still do the same thing with the P, colon, curly bracket. And we would say it's like a double R. And that would be your domain. Or sometimes people write it all the way out, all reals. And the same thing will be your range. So let's take a look at this absolute value function. This function here technically has arrows on both ends as well. So because it has arrows on both ends and we're talking about the domain first, bear in mind that the domain deals with the x value. So that's this line here. So how far is this going to go? It's going to keep spanning forever, forever. It's going to keep spanning forever, forever. Yes. So that means the domain will again be all real. So usually when you have arrows on both ends of your graph, your domain is all real. Now the range is not going to be all reals because our graph is not one arrow going up, one arrow going down. Our graph has a specific starting point. So let me take away that line. We're thinking about now, get it a little bit better. Now we are talking about this line. What's the lowest this graph goes? Well, the lowest point that this graph is now traveling is right here. So where is that at on our range? Our range is our y. So in terms of range, this graph, the lowest y that this graph goes is 0. So in this case, we would still do the range and we'll still have our colon, but we're gonna do set of y such that, that's like that little crazy line, that y would have to be greater than or equal to 0. So that would be your range for this particular graph, because the range never goes below 0. You have to state that the range would be all the values of y such that y is greater than or equal to 0. Hopefully that makes sense. If the graph was flipped downward, then it would be y, set of our y, such that y is less than or equal to 0. All right, clear out all these drawings. All right, so hopefully this is enough for you to kind of understand domain and range. So like with this particular graph here, I can't really tell you the domain because I don't have numbers, but your domain will be from 0 to whatever this number is because it's not continuous. And your range will be from whatever this number is on the y value through this number. So I'm going to give you some numbers just so we could pretend as we knew that we know. Let's say, for instance, this was an 8. Let's give this a value of 1. And let's say that this has a value of 7. So when we do our domain for this one, it will be that the domain would be set of all x such that x is in between, it will be 0 and 8. So you will have to put 0 less than or equal to x less than or equal to 8. And then you would close it out. And so you would do the same thing for y. The lowest y would be 1. And so you would say the range is the set of all y such that y is in between 1 less than or equal to y less than or equal to 7. So that's how that would actually go. So when you're looking at range, looking at domain, you want to say how far left does the graph go, how far to the right does the graph go. That's how you determine domain and range. All right, let's talk zeros of a function. Now, when we speak about a function zeros, we're specifically talking about where does the graph cross the x-axis. We're not necessarily talking about intercepts. However, zeros of a function is the same thing as that function's x-intercept. So where does it cross the x-axis is the same thing as zeros. It's the same thing as the roots. It's the same thing as the y-intercept. On this particular case, if I blow this up, the zeros of this function, they said, how many zeros does this function have? It would say it has 2 because it crosses the x-axis twice. So it crosses here, a -4, it crosses here at 0. So those are the 2 zeros. They said, what is the domain and range? If we look at domain first, you see how you have arrows on both ends? That means that the domain is all real. Now with range, it couldn't be all reals because this graph doesn't have one arrow going up and one arrow going down. So because of that fact, we have to look to see what's the lowest point on this graph. The lowest point on this graph, this so happens to be here, which the y value is at -2. So when we are stating the range of this function, the range would be the set of y such that y greater than or equal to -2. That would be our domain. Sorry, our range. That would be our range. Let's take a look at here. So it says, what appears to be the domain of the relationship or the relation shown? You know, the domain deals with x, so we could automatically cancel out A and C. Now, it could be a little confusing because it says B -7 to 7. These are just specific dots, and because they're dots, we could write out coordinates. So what we would do is use D because you do have -7 as an X, you do have -3 as an X, you do have 0, you do have 4, and you do have 7. So D would be your domain. Now, if this was some kind of continuous function, what I mean by continuous, it actually went like this, like you saw that it had like some kind of framework where all of these dots were connected. Then you could choose D as your domain. Because this is a discrete function where there's separate little dots, your domain has to be D. I hope that makes sense to you. Domain and range can be very tricky. So I hope you take a look at the practice. And if you have any questions, please feel free to get back to me. So what did we talk about today? We talked about that there is a way to make a relationship a function. A relationship is a function just based on the fact that there's a relation between X and Y. We also talked about what makes something a function. Something is made a function when there is no repeated X value. Lastly, we talked about, before lastly, we talked about intercepts. Intercepts are where the graph crosses the x-axis. That's also the zeros of the function. And we talked about domain and range. Domain, if it has arrows on both ends, then we know that the domain is probably going to be all reals. Now, if we have arrows going in opposite directions, where one is going up, one is going down, then the range is all reals. However, when the arrows are going the same way, we have to look and see what our range is. So hopefully this has given you an insight into domain and range, functions, and relations. If you have any questions, please feel free to get back to me, and don't forget to practice.